Hi, fifth grade. Today we're going to be doing Module 3, Lesson 4, and we're going to continue adding fractions, except now the answers that we get are going to be larger than 1. So you should have your Lesson 4 notes in front of you, and we're going to start off with kind of an easy problem. You probably already know how to do this first one because we are just solving for 1/3 plus 1/4. So just like the previous problems, we are going to set up both of our models to show what 1/3 and 1/4 look like. So I'm going to start off by splitting this first model vertically and shading in 1 part. And then I'm going to split up this model into 4ths and then also shade in 1 part. And notice how I split this one up horizontally and this one up vertically. Now after that, I need to make these models both look the same. So remember, we need those common denominators. So to do that, since I split this one up into 4ths, I need to split this one up into 4ths as well. So I will do that now. And then since this one originally was split into 1/3, then I need to split this one into 1/3 as well. So I'll split that right there. Now I will write my new equivalent fractions that I just created. So I have 1, 2, 3, 4. 12ths, because there's 1, 2, 3, 1, 2, 3, 4. 3 times 4 is 12. So I have 4/12ths plus 1, 2, 3 12ths. So I have 4/12ths plus 3/12ths, which equals 7/12ths. So we pretty much know how to solve this problem. This is just like the problems from our previous lesson. But now we're going to get a little bit trickier because now I'm going to have numbers like 1/2 plus 3/4. So when you take a look at these fractions, you might notice something. When I add 1/2 and 3/4, my answer is going to be larger than 1. And I'm going to show you what happens when we have answers that are larger than 1. So right here, we're going to draw 1/2. And then in my next model, I'll show 3/4. So since I have a 3 in my numerator, I'll shade in 3 parts, just like so. And then I will split up my models to show how they can have common denominators. So since I split this one in half, I'll split this one in half. And since I split this one into 4ths, I will split this one into 4ths, so that we can create those equal parts. Then I'm going to show what my new equivalent fractions are. So I have 1, 2, 3, 4 eighths plus 1, 2, 3, 4, 5, 6 eighths. And then I need to add these two fractions up. So I have 4/8 plus 6/8, and that gives me 10/8. Now you may look at that and say, I am done. But remember, this is something that we call an improper fraction. I really don't like leaving improper fractions around like that. So what I'm going to do instead is I am going to change this improper fraction into a mixed number. So to do that, you may remember a strategy that we learned from lesson 2, where we take improper fractions and we create a whole and then the rest of the fraction out of it. So what I'm going to do is I'm going to take a look at my denominator. My denominator is 8. So what I'm going to do is I'm going to think about, well, what number should I put up in my numerator that would give me 1 whole, or 8/8, which is 8/8. So 8/8 gives me 1 whole. And then I need to add the leftover to give me 10/8. So I would think about, well, 8 plus what is 10? Well, 8 plus 2 is 10. And then I'll leave my denominator the same. So I have 2/8. Now what I'm going to do is I'm going to rewrite this as a mixed number. So I have 8/8 right here. 8/8 is the same thing as 1. And then I have this 2/8 left. And I'm just going to add that to my whole number so that my final answer is 1 and 2/8. I can also simplify my 2/8 to show that it is 1 and 1/4 because I can divide both 2 and 8 by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So my final answer is 1 and 1/4. So as you can see, the process is almost exactly the same. We still are drawing the two models, we're still splitting them up so they have the same units. But instead of just stopping here with the answer I get after adding up my two fractions, I move on just a little bit more and I create a whole number, add the remaining fraction units, and then create a mixed number to show my final answer. Most of your answers for this lesson are going to look like this. They're going to look like a whole number and then a fraction added onto it, and you'll always have this improper fraction. So let's continue on with number 2. So we'll erase this, and we'll see how we can add different types of fractions together that equal more than one whole. So again, we draw our model. So right now I have 4/5. So I start vertically splitting this into fourths, and then fifths, and then since I have 4/5, since I have 4/5, I will shade in 4 of those parts. Oops. I'll shade in 4 of those parts. So we'll shade in 1, 2, 3, and 4. And then over here, I'll create a model to show half. So I'll cut this in half horizontally, and then shade in half of that. Now what I need to do is I need to have both of my models show like units or look the same. So to do that, since I cut this one into fifths, I'll cut this model into fifths. And then since I cut this model in half, I'll also cut this model in half. And now I'll need to rewrite the problem with my equivalent fractions. So I have 1, 2, 3, 4, 5, 6, 7, 8. And I have 8/10 plus 1, 2, 3, 4, 5, 5/10. So I have 8/10 plus 5/10. And now I need to add these two fractions together. Remember, my denominator doesn't change, so it's going to stay 10, but my numerator is going to be changed. So I have 8 plus 5, and 8 plus 5 is 13, which gives me 13/10. Now, we don't really want to stop here because this is an improper fraction. We really don't like improper fractions. So what we're going to do is we're going to create a whole number and then add the rest of the remainder. So to create a whole number, I want my denominator to be 10 because that's the denominator I see here. And I think about how can I create a whole? Well, I would need 10/10 to create a whole, and then I'll add the remainder. So if I'm trying to get to 13, I would think about 10 plus what is going to equal 13. Well, if I do 10 plus 3, that equals 13. And remember, my denominator stays the same. Now I have one last step that I need to do. I need to rewrite this as a mixed number. So I look at 10/10 and I know that 10/10 is one whole. Then I have 3/10 as my leftover fraction, and I'll just add that to my whole number. So my final answer is 1 3/10. And when I take a look at this, I'll check if I need to simplify it. Both 10 and 3 cannot be divided by anything else by the same number, so I am done now, and that is my final answer. So we're going to move on to problem 3 now. And as you can see, this lesson is very similar to lesson 3. The only thing we're adding on is that extra little step at the end. So our final problem is going to be 2/3 plus 3/5. So I have my model here to show 2/3, split it into thirds, and then I cut it, or I'll shade in 2 parts because my numerator is 2. And then I have my second model, and I'm going to split this model into fifths horizontally. So 1, 2, 3, 4. And I need to shade in 3 of these parts. So I shade in 1, 2, 3. And now I need to create that common denominator, so I make both my models look the same. So since I split this one into thirds, I'll split this model into thirds. And since I originally split this model into fifths, then I'll split this model into fifths. Then after that, we're going to write our new equation with our new equivalent fractions. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 15 total parts. I know I have 15 total parts because I have 1, 2, 3, 1, 2, 3, 4, 5, and 3 times 5 is 15. So I have 10 fifteenths plus 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 9 fifteenths. And now I can add these two fractions together because they have the same denominator. So we have 10 plus 9, which gives me 19. And then 15 is just going to stay the same. We do not add the denominators. So I have 19 fifteenths as my final answer. And what I need to do is I need to create a whole number out of this fraction right here. So I know that I need to have 15 as my denominator. That should not change. But I need to think about how I can create a whole number out of 15. So I would need 15 fifteenths to create a whole number out of that. And then after that, I need to think about how much more fifteenths do I need to add to get 19 fifteenths. Well, I know that 15 plus 4 is 19. Oopsies. 15 plus 4 would eventually give me 19. So 15 plus 4 would give me 19. If you have some difficulty finding this number right here, you could always do 19 minus 15, and that can give you your number right here as well. So now I have one last step to do. Now I just need to create my mixed number. So 15 fifteenths will give me 1. And then I bring on over my fraction, which is 4 fifteenths. So my final answer is 1 and 4 fifteenths. 4 and 15 have no numbers that they can both be divided by. So I am all done. And this is my final answer. So as we've gone over, pretty much everything is the same up until this point right here. Normally you draw your models, add the two fractions together, and get your answer. The only thing that's different for this lesson is you create a whole number and then add a fraction. And then get your final answer. So you guys are going to now work on the U-chart problem on the back. You should follow the exact same steps that we took here. And then let me check your answer when you are done. Good luck today.